Today is the 15th of May 2024. Um, I'd like to start another topic. We've done some probability, but I just want to revise what we've done and then add a little bit more for the higher students and then look at some questions again, okay? So, the ones we've done so far, if you are a foundation student, concentrate on those. But if you want to, you have higher students and you want um, to just get some few marks, let's do this because I'm going to do the revision and then I'll add a bit more. And the part I haven't added in the earlier videos, I'll tell you in this series. So instead of saying probability, I said probability revision 1, okay? Because if I do probability 1, it will confuse you with the other videos I did, which the foundation student can benefit on. But here, I'm solving more tricky questions and I'm going to show you how to look at those questions. Okay. We've been doing standard index form and I thought I'll wrap it up there. Any more questions, I'll bring it to possible exam questions or I will look at it at the status, okay, because it's not a lot. You can deal with it under 8 to 10 minutes. So we'll look at those. But for now, I want to just do this, look at this probability stuff again. Okay. Um, Thank you, everyone, all of my subscribers. Thank you so much. If you're watching our videos and you're benefiting from it, please subscribe, okay, like, share, follow us as well. I'll appreciate it a lot. And give us some nice, encouraging comments, okay? Uh, if the account is not yours, please, don't misuse somebody's account. If they allow you, uh, use it. If not, open your own account. It's better that way, or just ask somebody to help you open your own account. I appreciate it a lot. Then in the comment section, all the videos you see follow my notes/scripts, because when I upload it, I go back and watch it to see how I can improve. But there are times, because of like this mental math, it's a lot of numbers. So maybe I want to say root 2 and I end up saying 2. Okay, it's the same thing. It's on the script, it's on my notes. So follow it, please. Okay. Beware of scammers, please. Take care of yourself online. Okay. I keep on having emails, stuff. They are not, most of them are not true. Ignore them. If somebody texts you, sorry, in your inbox and is soliciting for funds for a charity or something under this platform, it's not coming from me. Don't entertain it. Okay, thank you very much. Okay, as I said, this is what we've been doing standard in this form. So if it's a topic you don't understand and you are contending with, go and watch those videos. Earlier on, I did some videos on those as well. Okay, it's very easy topic. and it counts all the time. They will ask you to leave your answer in the standard index form, or they will give you questions where you have to add, subtract, multiply, divide, or change a standard index form to an ordinary number, or um, change an ordinary number or your answer to the standard index form. Okay, so please, guess if it's something you don't understand fully, go and watch it, okay, and follow my notes last script. Today I'll start again. We want to do sets, okay. I just want to help you to be like a bit quick in your thinking. So, number one, because of the brackets, we are going to use board mass, okay? So, root 18 times root 2 divided by root 3. The root 3 is dividing everything in this bracket, okay? So now, um, root 18 times root 2. Now, because of this root 3, and I don't want to leave it in the denominator and then go back and rationalize, I will do root 6 times root 3. Okay? So that the root 3 can cancel the root 3. And then in the numerator, I'm left with root 6 times root 2. So this is what I've done here. Okay, so immediately I do that, I have root 8, but root 8 also, root 6 times root 2 is root 8. So keeping this root 2, root 6 can be broken down as root 3 times root 2. Root 2 is 2, so my answer becomes 2 root 3. Okay, now number 2. Root 32 times 2. Root 32 times root 2 divided by 8. Okay. Now here, okay, because of the 8, I'm going to do 8 times 4. So that's why it's good for you to be good in your times table. So root 8 times root 4 will become root 4 times root 8 times root 2, all divided by root 8. The denominator and the numerator root 8 will take care of itself. Root 4 is 2, so my answer becomes 2 root 2. I don't want to have the square root in the denominator, otherwise I have to go another step and rationalize. Okay, and you remember what I told you about leaving a square root in the denominator in math is classed as untidy. So that's why we do the rationalization, and I've shown you how to rationalize by single set and set with numbers. I've shown you that. We have the videos. Go and look at the set series, it's all there. Root 12 times root 8 divided by 48. Now, this um, can 8, I can do 6 times 12, or I can use this 12 and do 12 times 4. Okay, so root 12 times root 8 on the numerator, so I decided to do 12 times 4. So root 12 will take care of itself. Okay, now root 8 divided by root 4. Okay, this will become 4 root 4 times root 2. So we cancel it, the root 4's out, and we are left with root 2. Okay. Another one, root 6 times root 6 divided by root 3. So root 6, because of the root 3, I'll do root 2 times 3. So the root 3's will cancel out. Now, in the numerator, I have root 2, root 6. So root 6, I'll write it as root 2 times root 2 times root 3. Okay, so I have 2 root 3. So that will be my answer there. Okay. Now, today, okay, we are going to look at revision in probability. So it's not really revision, but I guess I want to revise what we've learned and then add a few stuff. So probability, we did relative frequency. Okay, there was a, a question where one afternoon, two boys just decided to throw the die for a certain number of time. Okay, and then they tabulated it. Okay, here is another throw of the buyer's die. So it's a one die. So they kept on throwing. So if they got a one, they tabulated it. So after 250 throws, they had one came 10 times. Okay, two came 35 times, three came 45 times, 4 came 30 times, 5 came 50 times, and 6 came 80 times. Okay, that was their result. Somebody else could have got another one in another group at the same place. That's why we call it relative frequency. Okay, that is what they got, and that is the information they are writing out. Now, we said that probability should always add up to 1 or 100%. You can't have a probability answer that is more than 1 or 100%. Okay, so if your answer is 1.25, then you know that you are wrong. Your probability answer should always be less than 1. Zero is impossible. It can happen. Okay, one is very it is happening. It has happened. 50% is halfway. It is like when you throw a coin, you either get a tail or a head. Okay. Um, when you throw a die, you either get 1, 2, 3, 4, 5, 6. So the probability of you getting any of those numbers is 1 out of 6. Because you can get a 1, you can get a 2, you can get a 3. And we've discussed all this in our earlier videos. So all I'm saying now, it's not in the notes, okay? But I have taught you those. So if you go into the earlier videos, you will see. So now the relative frequency. So they did 250 throws. Okay. So the relative frequency, that is the frequency. So it's for 1 is 10 over 250. For 2, okay, to get 2 on the die is 35 over 250. For 3 is 45 over 250. For 4 is 30 over 250. Okay. For 5 is 50 over 250. And for 6 is 80 over 250. Now, if you add the numerator, it should give you 250. So, over 250, so it should be 1. But when I use the calculator, okay, this is the numbers I got, and that should also be approximately 1. Okay, all this should be adding up to 1. Okay, so that is one example of relative frequency. Relative frequency. I've added them up for you, and it's up to 1 here. Now, a data survey. Okay, so here, um, it's not like a true or a die, okay, but it's like survey. So a color of a hat, for example, so you go to a carnival and then you decided to uh, stand upstairs somewhere whilst you watch the carnival, and then an elevated place, and then you realize that you can count um what are hats, okay, carnival people come and they are with different colors, okay, so you can count 45 green hats, uh 70 yellow hats, 50 red hats, 80 blue hats, 65 black hats, 48 white hats, and 42 silver hats. Okay, so that is so colorful and nice whilst they are dancing. So they are not having the same color. Everybody is um, using their own color, and then it's cheaper as well because you are not forced to go and buy something you don't have. You are creating from what you've got. So if it's a yellow material you got, you can use that and do your own hat and match yourself yellow. Okay, so when they counted it out of the 400 participants, these are the hats they got. So here, it's not a relative frequency like a true or a die that you can control. Here, you can also control it, but you can see it. So it's like a survey. It's like you go on the street and you count how many cars that are black, how many cars that are white, how many cars that are of a specific make, okay, how many cars that are black, how many cars that are um, white, how many cars that are blue, okay, so it's similar to this, okay, you don't have any influence why somebody chose to buy a black car over a red car. So in this case, this becomes a data and it's like a form of survey. So you can go into a neighborhood and then count all these colors of the car and the make, and then you tabulate it. Okay. So um here also, like in the carnival, you they didn't say that this group you have to dress specifically in the color. They just said of a color of your choice, dress colorfully and come. And when they came, these are the results they found. Okay, so now out of the 400, if you do the relative frequency, here it is a survey, okay, it is a survey, okay, you find the percentages, these are what you get. But when I added up, it was giving me three figures, decimal places, so it was like 1.01 something. So I approximated it to one, but it's just like it's a 0.01 is little. Okay, but if you add the numerators, it's equal to 400. So 400 divided by 400, again you get one. Okay, because this decimal I had to round up and round down. Okay, so this is why this is approximately. Okay, if you like, use your calculator and do it and see. And again, the point is probability is one maximum that is possible it will happen, or less, zero is impossible. Okay, um so that is it. Okay. And we discussed this very much in the earlier video, so you understand. Okay, now, so we talked about mutually exclusive events. Okay, now we use or a lot where you find the probability and add them up. Okay, so um, these are mutually exclusive events. You can only pick one at a time. Okay, so and after this I will show you another one because I said to you I'll discuss again the or rule or the end rule. Okay, so here I'm going to add the end rule so that you can see the difference. Okay, so maybe we'll do the end rule because we did a lot of mutually exclusive events and examples in the ones we did. Okay, um so we have 4 sweets. Okay, we have 4 red sweets. Okay, 6 blue sweets and 5 green sweets in a box. Okay, you can't look into the box, but that is what is in the box. Okay, now you go, you put your hand inside and you select one sweet at random. You are not supposed to pick two, you are supposed to pick one. So, and it's just one pick. Okay, it's not like you pick, put it back, pick, put it back. No, they are asking you to pick one. Now, what is the probability of selecting a green or a red sweet? Okay, now from this data here, the total sweet in the bag is 15. Yeah, so your denominator will be 15 for all the three. So if you want a blue sweet, it's 6 out of 15 here. Okay, if you pick red sweet, it's 4 out of 15. If you pick a green sweet, it's 5 out of 15. Okay, so now to pick uh, a green sweet and a red sweet, okay, it would be or a red sweet. Okay, that is if you dip your hand in without looking, you have a 5 out of 15 for the green sweet and 4 out of 15 for the um 5 out of 15 for the green sweet because we have 5 here, and a 4 out of 15 for the red sweet. So that is it. So in total, you have 9 out of 15, which when you cancel out, you get 3 over 5. Earlier on, I did blue and red. To get a blue, it's 6 out of 15 plus 4 out of 15. So to get a blue or a red, okay, so you can see, you can put your hand in. They want you to pick a blue or a red. So this is where the additional come in. It becomes um, mutually exclusive events. Okay. So here, if you are picking a blue or a red, it's 6 out of a 15 plus 4 out of 15 because you can either pick this red, blue, or red, which is 10 out of 15. That is 2 over 3. They could go ahead and ask what's the probability of picking a green and a blue. It's the same thing. Okay, so you do probability of picking a blue, which is 6 out of 15, and probability of picking a green, which is 5 out of 15, which would be a plus. So which would be 11 out of 15. Okay, that would be your probability. Okay, now Let's look at another example. There are sandals in summer. It's maybe white. The style is white and cream, silver and cream, and black and cream. Okay. Maybe you go to a shoe shop. It's in the shop. Okay. Now, the attendant goes in. This is what is in the storage: 7 white and cream, 14 silver and cream, 15 black and cream. Assuming they've mixed them up and they haven't um, marked them, and she's supposed to pick one. If she the total of the shoes in the 7 plus 14, 21 plus 5 is 26. So she can pick any of this because they have just mixed them up in an unlabeled box. Okay. So the probability of her picking a white and cream is 7 over 26. The probability of picking a silver slash cream is 14 out of 26. Probability of picking 5, a black slash cream, is 5 out of 26. Because in the storage, there are this amount, but they haven't labeled the boxes, so that attendant doesn't know. Okay. Now, okay, before they even label, okay. So now, what is the probability of getting a white or black cream sandals? So to get a white is 7 out of 26, and to get a black, okay, will be 5 out of 26. So 7 add 5. You remember when we did fractions, we said if the denominator they have the same denominator, we can add the numerators. So 7 add 5 is 12. Divided by 26, that's the total number of unmarked boxes. So we can have 6 out of 13. Okay, so that will be her probability. Here, you are only supposed to pick one, and you don't know what is in the box. Okay, they haven't marked it. Okay, so this is also another example of the or rule, where you have to add, and it's a mutually exclusive event. You are not picking it and bringing it back. Somebody comes, you go in there, you pick one, and then you come out, and then you realize that, oh, it was white or cream, or silver or cream, or black or cream. Okay. There's another example I want to show you. There are 3 white jumpers, 10 green shirts, and 7 red skirts in a lost property box. Okay, so this is a box. They've just piled everything, and then they realize that this is what they have, but it's not been labeled, it's been shut. So here again, you have 3 out of 20 for the probability of the white jumpers, 10 out of 20 for a probability of the green shirts, 7 out of 20 for probability of the red shirts. Okay, now what is the probability of pulling out, okay, one a red shirt now, or a white jumper? So there are 7 red shirts, so the probability of picking out one of those is 7 out of 20. And then the probability of picking a white jumper is 3 out of 20. It says 7 or that word here, or. Okay, so here again we have another example of mutually exclusive event. So adding the numerators, you have 10 over 20, which will be half. Okay, so it can either go one way, you can either pick um, either your chances of getting um, a white jumper or a red skirt is half. You can either pick any of those, because if you add them, um, there are 10 of them. Okay, if this is a green or red, because there are a lot of green, it increases your chances, so that'll be 10 out of 20 plus 7 out of 20. Okay. Now, what is the probability of pulling out a red skirt or a green shirt? Which I said 7 out of 20 plus 10 out of 20. So here you have 7 red and 10 green. So 17 out of 20. So you have a high chance of getting any of them. What is the probability of pulling out a jumper, white jumper? There are only 3 white jumpers, or 10 green shirts. So, uh, which is 10. So here again, you have 3 out of 20 plus 10 out of 20. So in total, you have 13 on the numerator divided by 20. Okay. So what I've said to you so far, these are mutually exclusive events where you can use the or rule. Okay, we've done this before. Event that cannot occur at the same time is mutually exclusive event. So you are going to pick one item, but they've asked you to limited you to come up to just dip your hand and pick one. So the probability is being calculated depending on the stuff in the box that you can see. Okay. Please subscribe, share, like, follow, give us nice comment, follow my notes/script today. Okay, it's like we are revising probability now, and then we are adding more stuff. Okay, so all this we've done, but I thought I would just do some revision with you to recap on what we've learned. Okay, which is our time is fast gone, and then add a bit more stuff for the higher students. Okay, so beware of scammers, take care of yourself online. Thank you so much for watching today's video with me, and I'll see you in the next.